An educator estimates that the dropout rate for seniors at high schools in Colorado is 12%. Last year, in a random sample of 300 Colorado seniors, 27 withdrew from school. At a significant level alpha equals 0.05, is there enough evidence to reject the educator's claim? Perform the hypothesis test using both the p-value method and the traditional method, then construct a confidence interval to confirm the hypothesis test. The first step, or the first part, in solving this type of problem is to read the question very carefully. The 12% is the claim about the proportion, whether the student drop out or not. So it is a categorical variable. And so this is the claim about the population proportion P. And the claim is that the dropout rate is 12%, so P equals 0.12. A random sample of 300 students or 300 seniors, so this is the sample size, n equals 300. 27 withdrew from school, so this is the number of success, if you will, if success means withdrawing from school. And we have the significant level given, so we have to use this. For the hypothesis test, the first step is to state the hypothesis. This is the null hypothesis and the alternative hypothesis. Remember that the alternative hypothesis is the one that does not have the equal sign, and the null hypothesis is the statement of indifference. First, we translate the English claim statement to symbolic form. The educators estimate that the dropout rate for seniors in high school in Colorado is, it is not more than, it is not less than, it is not at least, it is not at most, it is 12%. In symbolic form, P equals 0.12. P is 12%. The opposite of this statement is not equal to. The opposite of equal is not equal to. And P stays the same, and the null value 0.12 stays the same. The one that does not have the equal sign would go to the alternative hypothesis, P not equal to 0.12, and the null is always the statement of indifference, always the statement with the equal sign. Now, in this case, the initial claim is the null hypothesis. Keep that in mind when we make the conclusion. The next step is to compute the test statistics. This is the proportion z-test, and so z equals p hat minus the null value p naught divided by the square root of p naught, 1 minus p naught over n. But what is p hat? P hat is the sample proportion. In this case, the sample size n equals 300, and the number of success, the number who withdrew from school, is 27. And so p hat equals x over n, or 27 over 300. This is 0.09. And so the test statistic is p hat 0.09 minus the null value 0.12. The null value comes from the null hypothesis, divided by the square root of p naught, which is 0.12. 1 minus 0.12 divided by n. N is the sample size, 300. Put this in a calculator, we will get negative 1.60, rounded to 2 decimal places. This is the test statistics. Next, we find the p-value for the test. This is the two-tailed test because in the alternative hypothesis, the inequality is not equal to, so we will shade two sides. So it is the two-tailed test. And if it is a two-tailed test, the p-value is 2 times the probability of z. If the test statistic is negative, this is negative 1.60. So we're looking for the error on the left-hand side of a negative test statistic value. So P of z less than negative 1.6. Using either the table, the z table, or a calculator, we will find that this probability is 0.0548 rounded to 4 decimal places. But remember, this is the two-tailed test, so we would need to double that probability to get the p-value of 0.1096. The final step is to make the conclusion, to make the decision. The alpha, or the significance level given, is 0.05. And comparing the p-value to alpha, we see that this p-value is greater than alpha. And so we would fail to reject the null hypothesis. Remember that the null hypothesis was the original claim. We write the statement: we do not have sufficient evidence to reject the claim that the dropout rate for seniors at high school in Colorado is 12%. The original claim, or the initial claim, is that the dropout rate is 12%, but we failed to reject this, and so we just simply do not have evidence to reject this. We use the p-value method to make the decision, to draw the conclusion. If we use the traditional methods, then we would only use the z-test statistics for the population proportion test. With a two-tailed test with alpha equals 0.05, we split this alpha into two because this is a two-tailed test, and so the error on the right is 0.025 and the error on the left is 0.025. We then look for the critical value, which is still z, but we call it the critical value instead of the test statistics. The critical value for 95% in the middle, and therefore the total of 5% at the two ends is 1.96 and negative 1.96. Anything that is outside, or anything that is more than 1.96, we would reject the null hypothesis. Anything that is less than negative 1.96, we would reject the null hypothesis. And so the shaded regions here is the rejection region. We compute the test statistic, and it was z equals negative 1.60, and this negative 1.60 is not on the left-hand side of negative 1.96, and that is why we failed to reject the null hypothesis. And so if we do not use the p-value, then we would have to find the critical value so that we can compare it to the test statistic to make the conclusion. If we construct the confidence interval, recall that the confidence interval for the proportion is p hat plus or minus the margin of error, but the margin of error is z times the square root of p hat 1 minus p hat over n. P hat is 0.09 plus or minus, with the alpha, or the significant level, of 0.05. The two errors on the left and the right hand side total is 0.205, and so we need to construct a 95% confidence interval. With the 95% confidence interval, the critical value is 1.96, or approximately 2. We will use 1.96 because we found it already, times the square root of p hat is 0.09 times 1 minus 0.09 divided by n, but n is 300. This is 0.09 plus or minus 0.032. 0.09 minus 0.032 is 0.058, and 0.09 plus 0.032 is 0.122. If the null value is inside the confidence interval, then we would fail to reject the null hypothesis, because remember that the confidence interval captures the true unknown population proportion. In this case, the null value is p equals 0.12, so it is inside the confidence interval. And so it can be the population proportion, and that is why we failed to reject it. We come up with the same conclusion that we did in the hypothesis test. Anything that is outside of the confidence interval would be the rejection region. And so if the null value is not inside the confidence interval, we would reject the null hypothesis. But in this case, it is inside the confidence interval.